A very warm greeting to all. I am Awais Ahmed Husseini. I welcome all juries, all panelists, and all attendees for third international conference Techno-Societal 2020, hosted by that's very Pandharpur. So my paper title is Improving the Cooling Performance of the Deep Freezer by Incorporating Graphene Oxide Nanoparticle Mixed with the Phase Change Material During a Power Outage. So these are my content of the presentation: introduction, literature survey, methodology, synthesis of nanoparticle, experimentation, results and discussion, conclusion, future scope and references. Let us start with the introduction part. So as we know that the India is an agricultural based country and most of the GDP and progress is depends on the agricultural processes. Nowadays that cold chain is emerging technology in the globe as well as in India. So from few decades there has been improvement has to be made in case of the agricultural processes. Even though there are so many lacunas are there regarding that food safety and food quality, so it happens because of the so many reasons. So out of them the most important reason behind it is that power outage, and it affect on the performance of the refrigeration system. So as we know that the refrigeration industry plays a major and increasing role in the today's global economy with significant contribution made in the food. So that's why as far as that India is to be concerned, there are so many reasons through which that power outage exists because of the increasing the demand of the electricity, then maintenance problems are there, wind, then excavation problems are there. So that's why the power outage exists, and it affect on the quality of the food also. It affect on the performance of the refrigeration system, that is compressor. So most of the researchers are investigated different techniques to improve the performance of the refrigeration system. Out of them the phase change material is the best one and it is the economical one. So there are so many application of the nano phase change of the material. So that term nano along with that PCM is little bit different. So phase change material is the material which can change its phase continuously from the solid to liquid and vice versa, and it dissipates the energy. Okay, similar way, why to use that nanoparticle in phase change material? This is again important part. So we will discuss that part in the methodology. So in our experiment we are using that graphene oxide nanoparticle along with the different phase change material like NaCl, KCl as well as water. Okay, and we are improving the performance of the refrigeration system, that is deep freezer, and we are extending the cooling performance up to 6 to 7 hours as far as using that nano phase change material. So there are so many phase change materials are available in the market for which is suitable for the lower temperature application. That is organic materials are there, inorganic materials are there, and combination of both, that is eutectic. The speciality of all the phase change material is a good phase change temperature, good latent heat stability, then recyclable, then good they are having the low cost and volumetric efficiency is also high. So when we use that phase change material along with the nanoparticle, so it will improve the system performance by maintain the precise temperature, reduce the dependency on the power source, thermal management to increase their efficiency, shift peak power load and off peak time. So the overall the compressor on off time will also goes on reduces, and similar way in order to it will affect on the performance of the refrigeration system, and we can save the electricity up to 20 to 25%. So there are so many researchers are work to improve the performance of the refrigeration system for lower temperature application. So many researchers are works together to improve the system performance by various techniques. The Mohammad Jabri investigate or he studied different methods to improve the performance of the refrigeration system, like energy efficient compressor, enhancement of the thermal insulation, similar way implementation of the phase change material for lower temperature application. So he concluded that the phase change material is the most innovative technique to improve the performance of the refrigeration system, and we can improve the system performance by 15 to 20% as compared with the normal setup. Similar way that Razul Rahman investigate the water is used as a phase change material in the refrigeration system, and we can improve the system performance, that is COP, around 55 to 60%. Similar way that Lob Ridalda studied the vulnerability of the spoilage of the food as far as that Indian climatical condition is to be concerned. Similar way that Duke Con investigate or he studied different thermal energy storage material, that is different phase change material whose works in between -20 to 200 centigrade. Similar way that Veera Kumar studied different application of the phase change material for the n number of the applications. So these are the some most important literatures which is used related with the phase change material. After means the next slide is related with the methodology. So in methodology, first we identify the problem statement. The problem statements are temperature fluctuations. So what exactly that temperature fluctuation is? So temperature fluctuation exists when the power outage is arises. So because of that, the temperature fluctuation, it affects the performance of the food quality as well as food safety. So there are so many limitations of the phase change material as far as that heat transfer and that latent heat to be and thermal conductivity is to be concerned. So we are deciding to use nanoparticle along with the phase change material. We are deciding to use a phase change material as NaCl and KCl and water, because their melting point is very less as well as boiling point is very less. Similar way, when we talk about their price and availability, it is very easily available and low cost available in the market. So the mass fraction is also most important. We are selected very less mass fraction of NaCl and KCl, like 3 to 5%. Because if we increase their then percentage, then affect on the suitability of the material like copper as well as that stainless steel and MS material. So similar way, that diffusivity is also goes on decreases. We are using graphene oxide nanoparticle because it is having good thermal conductivity, good latent heat, good specific heat, as well as good density, good diffusivity, and we are keeping their mass fraction 0.5 because why not the more amount? Because if we increase their amount, then thermal stability goes on reduces and their lubricity also decreases and its viscosity goes on increases. So in order to mix with that graphene oxide nanoparticle along with the phase change material, we are using that ultrasonic agitator. It is available in our laboratory. We are keeping that Nano Pcm mixture with at near about 70 to 80 degrees centigrade for 3 hours, and after mixing this combination, we will get that Nano Pcm combination, and after that we start to manufacture experimental setup by studying all properties, and after mixing that Nano Pcm. Okay, so we are decided to use deep freezer. So deep freezer is mainly used to keep or to store the temperature sensitive product like ice cream, milk product, and vaccines etc. So we are selecting 200 liter capacity of the deep freezer, and in that we are implementing different Nano Pcm containers. But these containers are made by stainless steel material in order to avoid the corrosion effect, because as well as its thermal conductivity is also great. So similar way, we are start the experimentation but during the power on and during the power off situation, and after that results, discussion, conclusion, then future scope, and then we stop our experiment here. So these are the synthesis of the Nano Pcm. There are so many methods to manufacture that Nano Pcm. Out of them, single step method is there, two stage method is there. We are selecting two stage method. So initially we are taking water as a base fluid, and in that we are using that KCl and NaCl as a phase change material, and in that we are using that desired quantity of that or selected quantity of the graphene oxide nanoparticle, and we keep that mixture at 70 degrees centigrade in ultrasonic agitator for 3 hours, and at the end we will get that Nano Pcm. Similar way, as far as that experimental setup is to be concerned, the basic working or the working principle behind that experimental setup is when the compressor is on condition, at that time only the refrigerant present evaporator means absorb the energy from the inside space and it produces the cooling effect. When the compressor is off, at that time the temperature inside that cabinet start rising, and due to that the temperature increases inside that cabinet, it affect on the performance of the food quality. So in order to avoid that, we are implemented Nano Pcm containers in the inner surface of the deep freezer. So the main working principle behind it is that during that charging process, that phase change material, Nano Pcm material changes its phase from the liquid to solid, and it stores some latent heat. And when power outage exists or when temperature fluctuation exists because of that power outage effect, at that time it dissipates that energy, that Nano Pcm container dissipates that energy to the surrounding area or that container cooling chamber, and they start changing its phase from the solid to liquid, and we can prolong their cooling time. Okay, as well as because of that we can extend the compressor on time. So in that way we are reducing the electricity consumption as well. As far as that, this is the working principle, and as far as that experimental setup is to be concerned, the experimentation setup consists of the test facility like pressure gauge, energy meter, LPHP cutoff, then Nano Pcm containers. We are using that NaCl and KCl as a phase change material, and we are using that graphene oxide nanoparticle. So initially we are taken 10 readings during power on mode, and after that we just switch off that particular power supply, and we take 20 to 25 readings by considering the 15-minute time interval, and we study the cooling time required with and without use of the Nano Pcm. So similar way, this is the combinations. There are total 4 combinations are there. In first row there are 2 combinations. Initially we are taken 3% of the Nano Pcm and 0.5% of the graphene oxide nanoparticle as then water as a base material. Similar way, in second times we use that 5% of the NaCl and 0.5% of the graphene oxide nanoparticle along with the water as a base material. Similar way, in second time there are again two categories. In first time we are using that 3% KCl and 0.5% graphene oxide nanoparticle along with water as a base fluid. Similar way, next time we are taken that 5% of the KCl and 0.5% of the graphene oxide nanoparticle along with the water as a base fluid. So after experimentation, these are the results and discussion. So the first graph is related with the comparison between evaporator temperature or cooling chamber of the 3 and 5% of the NaCl along with 0.5% of the graphene oxide nanoparticle with the absence of the Nano Pcm, with and absence of the nano phase change material. Okay, so here you will get idea about that. Blue line indicates that temperature goes on increases inside the deep freezer when we never use that Nano Pcm container inside the deep freezers. So by using NaCl combination, that is 3% and 5% along with the 0.5% of the combination, it is possible to maintain the evaporator temperature 3 to 5 degree and we can extend the cooling time up to 6 to 7 hours. So similar way, it seems that NaCl plus graphene oxide nanoparticle will keep evaporator temperature constant for a longer duration of the time even though the power outage exists. Similar way, this is the second graph related with the KCl along with the that graphene oxide combination. So here with the help of that KCl 3 and 5% of the mass fraction along with the 0.5% of the graphene oxide and water as a base fluid, it is very necessary to maintain the temperature around, we are keeping the temperature maintain around 6 to 7 degree for 6 to 7 hours. So it seems that the KCl plus graphene oxide nanoparticle will keep the evaporator temperature constant for the longer duration of the time even though the power outage exists. So that here also that blue line indicates the temperature continuously goes on increases when there is absence of the Nano Pcm. So this is the main important thing, and this is the miracle results we will get with the help of that nano phase change material. So let us start with the conclusion part. So as far as that research explore the performance improvement of the refrigeration system using nano enhanced phase change material. So in conclusion, I suggested that the most important thing is there are so many limitations of the phase change material. So like low thermal conductivity, low latent heat, low durability. So in order to improve their performance like thermal conductivity as well as their diffusivity as well as thermal change temperature, we are using nanoparticle. So by using 3 and 5% of the NaCl plus 0.5% of the graphene oxide combination, it has been possible to maintain the evaporator temperature 3 to 4 degree and 3 to 5 degree respectively for a 6 to 7 hours time span. Similar way, by consideration of the 3% and 5% of the KCl along with the 0.5% of the graphene oxide nanoparticle, we are keeping the inside cabinet temperature 5 to 6 and 6 to 7 degrees centigrade for 6 to 7 hours. So we can extend the cooling time of the refrigeration system or inner space or cooling chamber even though power outage exists. From the experimentation, it has been proven that the use of the Nano Pcm on the evaporator side maintain a constant temperature for a longer duration of the time along with the 6 to 7 hours even though the power outage exists. The power consumed with the advancement in the setup is lesser as compared with the conventional one because we are extending the compressor on off time. So due to that, it affect on the system performance and power consumption goes on reduces. So I suggested that the thermal energy storage is most efficient method to correct the gap between energy supply and demand by the nano phase change material. So these are the references which is used in this research work. Thank you very much.